everyone, my name is Sanvi and I'm a junior at Stevenson High School. I hope you guys are all staying safe during this time, and this presentation is the sixth part of an online community initiative designed to introduce STEM and medicine to students who might not have the opportunity to explore these careers. And today we're going to talk a little bit about mechanical and electrical engineering. So electrical engineering is basically studying, designing, and applying equipment, devices, and systems that use electricity. So as I'm sure you can imagine, this can involve a lot of different things. I have a few listed right here. So the first one is generators. And generators basically convert kinetic energy, which is the energy of movement and moving different parts and different things, into electrical power that we can use and that we can harness. Next we have microchips, which are used in many technological devices, like really anything that you can use, like phones, TVs, GPS, a lot of different things like that. And then specifically more towards the designing of devices, we have CAD, which is computer aided design, and this can be used to design like really any kind of product that people would want. So what mechanical engineering is a really broad discipline of engineering, and it combines engineering, physics, math, and material science. And a mechanical engineer would design, analyze, manufacture, and maintain mechanical systems. So because mechanical systems are involved in many, many different industries, mechanical engineers can work in many different industries. And a few of the main ones are automotive, which has to do with cars and trucks and things like that, and then aerospace, which has to do with planes and rockets, and then we have biotechnology, which has to do with using biological products for a technological purpose. So some careers in electrical engineering are telecommunications, which involves using computer systems and other devices to communicate, and it can include things like installation, repair, design, and testing of all these different devices. So next we have aerospace engineering, which is developing aircrafts and spacecrafts, so things like planes, rockets, any kind of like space rovers, satellites, things like that would be involved in aerospace engineering. Next we have research and development in electronics, which is a really broad discipline again, because it involves designing new electronic products or processes. So this can involve really any type of innovation that you can imagine. Like, people are doing so many different things to make our lives easier, like every single day. So some careers in mechanical engineering are architectural and engineering managers, and these people can oversee any architectural projects like constructing a building or a skyscraper, or they can even oversee the design process of a product or even of a structure. Next we have materials engineering, which is the creation of new materials to be used in different products and different devices. So certain products and devices might have a certain standard of what material they think would work the best in their product, or what kind of qualities they would need in a material to make their product work the best. And a materials engineer would do their best to fulfill all of that criteria. Next we have nuclear engineering, which is the development of more efficient methods to harness nuclear energy and radiation. And nuclear engineering is just one of the fields that is moving towards a more sustainable approach towards energy, and because of that, it is predicted to grow a lot more in the future. So now we're going to get into some ways you guys can explore electrical and chemical engineering, and because these are both like engineering disciplines, there is a lot of coding involved depending on what you do. And learning to code is something that really anyone can do, especially nowadays. There's so many free resources out there that really break it down for you and make it really simple and easy to learn. So I have a few listed right here, which are Code.org, Codecademy, and even Khan Academy has some stuff. And additionally, I also have to look for internships at local companies, which can be a really great way to get some more hands-on experience and really immerse yourself in these fields. So some of the latest advances in electrical engineering, first one that we have is a nanotube transistor. So a normal transistor can either amplify or switch electronic signals, and this is used in a lot of different devices, but an extremely small nanotube transistor would be much quicker and would use less energy, which can really increase the efficiency of all the devices that we use on a daily basis, and can even make them much cheaper if these are able to be produced at a high quantity. Next, we have drones. Drones are, I'm sure you guys know, are self-flying machines, and they have many, many applications. And if they can be scaled appropriately and accurately, they can really change the way that we live our lives. Like, they could change shipping and delivery. They can change like disaster management, many things like that. They could have many different applications in. And next, we have electric cars. As I'm sure you guys know, again, electric cars are much better for decreasing carbon emissions than gasoline cars. And being able to increase the efficiency and accessibility of electric cars while decreasing their cost can make them accessible to a lot more people. And this can greatly decrease carbon emissions and really reduce the effects of climate change. So next we have the advances in mechanical engineering. So the first one we have is biofuel production, and this involves using biomass and biological materials as fuels. And this can, again, greatly reduce carbon emissions and is much more sustainable to using like a fossil fuel approach. Next, we have newer designs for harvesting solar energy. So solar energy is one of the best forms of renewable energy. However, it can be difficult to harness to have as high of an energy output as you would with some fossil fuel energy. So being able to optimize this energy output is really essential to ensuring that solar energy becomes much more widespread and can be used on a much larger scale and can be really taken like to anywhere in the world. Kind of building off of that, we have increasing the efficiency of like any renewable energy sources in general. So this can involve like wind, solar, like hydroelectric, and all of these are much more sustainable options towards using fossil fuel. And a lot of mechanical engineering these days is being focused towards this because of how a lot of people are kind of worried about how the way that we're using energy today isn't really sustainable and won't serve us in the future. So if we figure out how all this renewable energy stuff works now, we'll be much more prepared for the future when maybe we won't be able to use as many fossil fuels. So yeah, that's all we have for today. Thank you guys so much for listening. Hope you have a great day. Bye.